Welcome, architects and engineers. Today, we are tackling the chaotic reality of production AI. We are diving deep into error handling, specifically focusing on how to manage tool failures and hallucinations so your agents don't crash when the real world pushes back. Let's get started. Let's define the battleground. When you deploy an AI agent to production, you are combining the probabilistic nature of large language models with the unpredictable nature of external APIs. This guarantees two things: your tools will eventually fail due to timeouts, and your LLM will eventually hallucinate bad parameters or non-existent functions. Traditional software engineering treats errors as fatal exceptions that crash the app. In agentic architecture, we must shift our paradigm. We must treat errors as observations. When a tool fails or an output is malformed, we don't crash. We feed that failure back into the LLM's context window so it can reason about what went wrong and try again. Today, we will master the techniques to gracefully catch these tool failures and suppress cognitive hallucinations. Looking at this concept map, we divide our agent's failure modes into two branches. On the left, systemic tool failures include network timeouts and malformed JSON arguments. We fix these with retries and prompt mutation. On the right, cognitive hallucinations include invented parameters and false confidence. We mitigate these using self-correction loops. Mastering all these recovery paths is how we build enterprise-grade resilience. Let's look at the absolute basics: graceful tool degradation. If your agent calls a custom Python tool and that tool throws a standard value error, your entire application will crash. To prevent this, frameworks like LangChain provide a brilliant mechanism, the handle tool error flag. By setting this to true when defining your tool, the framework wraps your function in a safety net. If an exception occurs, it intercepts the error, prevents the crash, and converts the exception trace into a standard string. It then passes this error string back to the LLM disguised as a successful tool observation. This is incredibly powerful. The LLM reads the error, for example, API unauthorized, or syntax error, realizes its mistake, and uses its reasoning engine to autonomously correct its arguments and fire a new tool call. This sequence diagram shows the safety net in action. The LLM invokes a tool, and the external API throws a fatal exception. Instead of propagating the crash to the user, the framework catches it. It returns the error string back to the LLM as an observation. The LLM reasons about what went wrong, fixes its arguments, and successfully invokes the tool a second time. Feeding errors back to the LLM is great for logic mistakes, but what about transient errors? If your agent hits a 429 rate limit or a momentary network blip, making another LLM call to reason about it wastes tokens and money. For these, we use infrastructural retries and fallbacks. In LangGraph, you can attach a retry policy directly to any node. If the tool node throws a specific exception, the graph engine automatically pauses, applies an exponential backoff, and retries the execution without bothering the LLM. Furthermore, what if the LLM provider itself goes down? You can append dot with fallbacks to your model definition. If your primary GPT for model times out, the framework instantly falls back to a secondary model, like Claude or a local open source instance. The user experiences a slight delay, but the system never crashes. Trace the flow of execution here. When an action hits the execution node, a success moves it forward. But if a 429 rate limit occurs, the retry policy intercepts it, applies exponential backoff, and loops back automatically. If the LLM API completely fails, the system triggers a fallback, activating a backup model to safely route the execution to the next step. Now for a deep dive into deterministic failures. Imagine your tool requires strict JSON, but your LLM outputs a string with markdown backticks. A blind infrastructural retry will fail infinitely because the LLM is deterministically making the same syntax mistake. We solve this with adaptive retry and prompt mutation. When the JSON validation fails, we don't just ask again, we mutate the prompt. LangChain provides the retry with error output parser. When a parse fails, this parser intercepts the crash, bundles the LLM's broken output along with the exact parsing error, and sends it to a dedicated fixer LLM prompt. The new mutated prompt essentially says, you generated this output, but it failed with this exact error. Please fix your formatting. By tightening the constraints and explicitly showing the model its mistake, we successfully repair broken outputs mid-flight and keep the agent moving forward. This is the architecture of an output repair loop. The LLM generates an output that hits our JSON validation. If it's invalid, it is routed to the retry with error output parser. This component mutates the prompt, appends the specific error message, and issues a fixer LLM request. The model corrects its syntax, passes validation on the second pass, and the tool executes flawlessly. Tool exceptions are easy to spot because they crash. Hallucinations are silent killers. Your agent might invent a perfectly formatted, completely fake customer ID and execute a tool with it, producing disastrous business results. To mitigate cognitive hallucinations, we build self-correction loops into our graphs. This pattern, often called self-corrective RG, uses an LLM as a judge. Before the agent takes a final action or returns an answer to the user, the execution flows into a verification node. This node uses a strict prompt to ask, is this answer fully supported by the retrieved facts? Does this tool parameter actually exist in the context? If the grader detects a hallucination, a LangGraph conditional edge routes the state backwards into a refinement node, forcing the agent to discard the fake data and try a new reasoning path. We programmatically enforce truthfulness. Look at the self-correction cycle. The agent drafts an answer, which must pass through the green verification node acting as an LLM judge. If the output is grounded, it proceeds. If a hallucination is detected, the flow is instantly diverted to a refinement node. Here, a critique is injected, forcing the agent to regenerate the output until it satisfies the strict factual constraints of the judge. Let's apply all these safety nets to a high-stakes, real-time use case, a resilient enterprise loan processing agent. The agent needs to call a run credit check tool. First, the credit bureau API times out. No problem. LangGraph's retry policy catches the 503 error, waits 2 seconds, and retries successfully. Next, the agent tries to send a string instead of an integer for the ID. The tool throws a validation exception. Because we enabled handle tool error, the agent reads the error, realizes its syntax mistake, and fixes the payload. Finally, the agent tries to approve the loan by hallucinating a non-existent corporate policy. Our self-correction verification node intercepts the draft, realizes the policy citation is fake, blocks the action, and forces the agent to regenerate a denial based strictly on actual retrieved documents. Our system survived a network crash, a syntax error, and a hallucination, all autonomously. This state diagram maps our loan processor's gauntlet. The credit check tool survives an API timeout via retry policy, and survives a type error via adaptive retry. Moving forward, the draft approval enters the verification node, where a fake policy hallucination is caught. The flow forces a regeneration, ultimately reaching the safe, factual final output state. To conclude, building production-ready agents is about defense in depth. You must layer your protections, infrastructural retries for network chaos, adaptive prompt mutation for syntax failures, and semantic LLM judges to catch cognitive hallucinations. But even the best agents reach their limits. When all automated recoveries fail, you must implement the agent call's human pattern. By pausing the LangGraph state, you can escalate the precise error and context to a human operator's dashboard, ensuring absolute safety. Never deploy without observability. Use LangSmith to trace exactly where your tools break so you can continuously refine your system. Remember, in Agentic AI, errors are features, not bugs. They're the feedback loops that make your agents smarter. I want to invite all learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Keep building resilient systems. Our final mind map consolidates resilient agent architecture into 3 pillars. Infrastructural handles the network with retries and fallbacks. Cognitive handles the LLM's brain with prompt mutation and self-corrective graders. Operational bridges the gap to reality, utilizing LangSmith observability and human-in-the-loop escalation as the ultimate safety valve. Master these, and your agents are production-ready.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.